Okay, in this video we're going to take a look at half-life decay. So the key here is in the words half-life. Notice the base is 1/2. That tells us that we have a decreasing function, that it's decaying. Okay? And a sub 0, remember that this represents the initial amount. Okay? All of that information is down here. It tells you where to put everything. Okay? So another thing to note, that the time and how long it takes it for it to decay a half-life have to be in the same units of time. So let's take a look at this example. It says the half-life is the amount of time it takes for half of the atoms in a sample to decay. So if we start off with a certain amount of atoms, how long does it take for us to have half the initial amount? So a chemical substance will decay by a half in 3 hours. Now, it tells us that it will decay by a half in 3 hours. So the half-life is 3 hours. This would represent your K value. Back down to the formula. K equals half-life, goes in the denominator. Complete the following table for a 200-gram sample. So, notice that we start with 200 grams at 0 hours. Okay? So that's going to, if we were to write the formula, which we need to do here, that's going to be our initial amount. Or our amount when t equals 0. So we're going to start off with 200. This is a half-life problem. It says decay by a half. So our base is going to be 1/2. And then our time is t, our independent variable, over our half-life, which is 3. So this is the formula for this problem. So now, let's fill in our table. So let's start off with 3. So 3 over 3 is 1. 1/2 to the first power is a half times 200, which is 100. Well, that makes sense. It says the half, it will decay by a half in 3 hours. So how many hours has passed? 3 hours. So it decayed by a half. Half is remaining. So notice another 3 hours passes. So how much should be remaining? Correct. A half. A half of 100 is 50. Let's plug it in and see if we're right. So 6 over 3 is 2. 1/2 to the second power is 1/4. 1/4 of 200 is 50. Another 3 hours has passed, so we have half left. Get the idea? It says how much will be left after 10 hours? Okay, well 10 hours, if we look at our table, it's going to be less than 25. So let's plug it in and see what we get. So we're going to have 200. Our base is a half, and our time is 10 over 3. Now I want you to keep in mind that our time is in hours and our half-life is also in hours. They have to be in the same time frame. Okay, so I'm going to use my calculator for this one. So 200, and then caret, I'm going to go ahead and use 0.5, easier to put in. And then raised to the and it's going to be 10 divided by 3. Should be a little less than 25. A little bit more than a little less. 19.8425. I'm going to go ahead and round it to 1 decimal place, and that's going to be in grams. It's going to be in grams. So approximately 19.8 grams. Okay? All right. On the back side, compounding interest. So this is a compound problem. If you look in the problem, you see the word compounded. And when you see the word compounded, you go to the formula that says compounded. This one is compounded quarterly. Okay, so that would be 4 times in a year. $4,000 is invested, so that's going to represent our principal. It's at a rate of 6%. That's going to represent our rate, which is going to be 0.06. It says write a formula. So again, we go down here to our little formula. We know that our principal is 4,000. That's how much we begin with. We know our rate is 0.06. And we know that the number of times it's compounded, N, tells you right down here, is compounded quarterly. So that would be 4. And then it's N times T. So in this case, it's compounded quarterly, so 4 times T. Remember, what's inside the parentheses here is our base. So if we really wanted to calculate what that base is, we're going to do the simplify that quantity there. So 1.015, which is a number greater than 1. So we do have a growth here. We do have a growth. All right. So next thing we want to do is we want to go into our graphing mode. We're going to plug in our formula. We could do this by hand, but it's much faster doing it this way. And we found out that our base is 1.015 raised to the 4t. In this case, we use an x. It's our independent variable. Okay, enter. We don't need to graph this. If we were to graph this, we would need to set up a window here. So let's go ahead and do Control T. All right, so first compound, if we plug in and so after 5 years we would have, I can get over here to my table, technical difficulties of course. So $5,387.42. Now on the next question, it says how much would be in the account after 5 years if the interest is compounded monthly? So this number would change to monthly, which would be 12 times a year. So we would have 4,000 times 1 plus the rate, which doesn't change here. What changes is it's compounded monthly, so 12. And that would be 12 times 5. So let's go ahead and figure that one out real quick. So we have 4,000 times 1 plus, and it's going to be 0.06 over 12. Okay, raised to the 12 times 5, which is 60. All right. So $5,395.40. Notice it's a little bit more than being compounded quarterly. This was 4 times. This time was compounded 12 times. Okay. Number 5 says find the principal needed to have $5,000 after 10 years at 6.5% compounded monthly. So now we're trying to find the principal, and we're given the amount we want to end up with. So the amount we end up with is going to go in for A of t. We're looking for P. And so we're going to fill in the rest of this. It's 1 plus the rate. And it's compounded monthly, so 12. And then 12 times 10. And we're trying to solve for P. So the first thing I'm going to do is I'm going to simplify this side. So when you're simplifying something, you start with the grouping symbol. So we're going to have, inside the grouping symbol, we're going to have 0.065 divided by 12 plus 1. Okay, raise that to the 120th power. Okay, so we have and solving for P, we're going to divide by that decimal, and we want to use as many decimals as possible. Don't round, please. Do not round that to 2 or 1.9 for that matter. So we're going to have 5,000 divided by so we need to invest $2,614.82 as our principal. Okay, see you guys in class tomorrow.